Part A, 4 1-ohm resistors are consecutively connected in a circuit such that each node only connects a pair of them, which in this case refers back to the resistors. What is the total resistance of them, referring to the resistance equivalent of all the resistors? So I drew a diagram of the meaning of the words. You will notice that each pair of these resistors, pair 1, pair 2, pair 3, are connected in series, which means they each exclusively share one node. If a third resistor was connected to either of these nodes, then these pairs would not be connected in series by definition. Because they are connected in series, we can find the resistance equivalent by simply adding them. Therefore, our total or resistance equivalent of these resistors equals 4 ohms. Part B, if a 4-volt battery was connected between any two of the resistors, what would be the voltage across each resistor? Again, I drew a diagram that expresses the meaning of the words. This is a 4-volt voltage source, could be a battery, and these are the same 4 1-ohm resistors. In a series circuit, you can calculate the voltage across each resistor by applying the voltage divider formula, which states that V subscript R, referring to the resistor whose voltage you are searching for, is equivalent to the source voltage, in this case the 4 volts, multiplied by the resistance of that resistor divided by the total resistance. So in this case, because the resistance of all the resistors equal 1 ohm, we can find all of their voltages simply by applying the voltage divider formula to any one of them. So in this case, VR equals Vs, which is 4 volts, multiplied by the resistance of one of the resistors, which is 1 ohm, divided by our total, which we found earlier, it's 4 ohms. You'll notice that the ohms will cancel. 4 divided by 4 equals 1, and the unit associated with that quantity is the volt. Therefore, 1 volt is the voltage across each of these resistors. And you'll also notice that that sums to 4 volts. Therefore, Kirchhoff's voltage law reinforces our calculation with the voltage divider formula.